Hello, everyone. I'm doing some processing coding today in Java. And what I'm going to be doing is extending the capabilities of the base class to handle some special functionality that I want to implement and I want to reuse between my sketches. So first of all, I'm not using the processing IDE because I want to use external libraries and my own libraries. And so I have this implemented as a Maven project, and I'm extending the PApplet class, which is basically the base class for processing that has the draw method and all the other methods. So you can extend that. And subsequently, my sketches are going to extend this AlgoMotion PApplet class that I'm working on to have access to all these abstractions that I'm creating on top of the PApplet class. So I've already done a fair bit of work on this off stream. So I'll start by just quickly walking through what we already have. So this class is parameterized by a type that extends message, and this message is the protocol buffer base class. Every proto, which is Google's serializable data implementation, a lot like JSON, but better serialization, and you get automatic method generation and class generation across several languages. So it's a very useful and portable framework for storing data. So I use proto buffers to parameterize all my sketches. So I set things like the width and the height of the sketch, any colors that I might want to tweak, timing data, anything I want to put in the parameters and be able to tweak, I store that in a proto buffer. So I'm passing that as a generic type to this class, whatever that protocol buffer will be. And it gets stored as an instance member here. So I can call in the base class. I've just left it. Actually, I had package visibility. This should be public because I'm going to be extending this from different packages. So generally, it's not good practice to have instance members public. You want to restrict that to instance methods. But processing sketches are a bit different. You wouldn't treat it like you would a large software system at a big company or something. So you can take more liberties with some of the best practices, I would say, because the final deliverable that you're making is just a processing sketch. So I'm not too worried about the encapsulation of these instance variables because they're only used in processing sketches, which is basically a piece of art in some sense. And so in addition to the proto, I'll maybe talk about these parameters later. I have the background color. So I'm enforcing that I always need to add a background color. Or rather, I can add a background color parameter in my proto, and it'll automatically get pulled in by this class, so I don't have to keep rewriting the code to pull the color string specification for my proto and store it in here. Some of these comments aren't accurate yet. I was planning to search through the proto using reflection to look for every color field with underscore color, but I'm rethinking that now. I guess we can talk about these other fields. So this scale factor is just for resizing the whole scene. Say I want to do it at 720p instead of 1080p just for development and just faster rendering of the frames. I can just specify a scale factor in my proto as scale factor. Maybe I'll show a proto I used for a test example. So this would be the most basic proto given what I have right now. You've got the width and height as integers, 32-bit integers. A string background color, which I specify as an RGB string like this with 3 numbers, something like that, and optionally an alpha value. between 0 and 1, which I'm calling opacity. And also this scale factor, which I was just talking about, that can resize my sketch. And so one of the methods that I implement here is this SCL, to scale any value by that scale factor. So if I want to be able to scale the whole drawable sketch, I can just invoke SCL or SCL round on everything, depending on what it is. And in the settings here, which is the first method that gets called even before the setup method by the processing framework, I am using the Apache Commons command line library to read the command line parameters that I've defined. And basically the only one is this params, which is a file name that points to the text proto on disk that contains the actual parameters I want to use. So an instance of this proto. So in my test, it would look something like this. Typically we'll have a lot more parameters than just these 4. But that's how you can specify it and tweak these values to whatever you see fit. I have the background red in this example. And these options are defined down with this create options method. So I just define this. In addition to the help option, I have params, which is just the file name of my text proto. And then the size gets called. So again, it's assuming that there's a width field and a height field in my proto, which I get by reflection within Java. Protos automatically generate these methods, these getter methods, accessor methods called get and then your field name in camel case. So you define it in snake case in the proto, like this, scale underscore factor, everything lowercase. And then in Java, it translates that to a camel case accessor. And so there's a little detail when you're not, or when I'm in unit tests for this, which I've written a few, this will crash the unit test because processing has some code to make sure that size is only called from the settings method by the framework. And I'm manually calling the settings method here in my unit test, which is what crashes it. So it says size can't be called here. So the kind of ugly workaround is that I just check if we're in a testing state, and only then do I call the size method to actually change the size of my sketch. And after I read the parameters from disk here, which is this method, it just reads creates an input stream reader and uses the text format method from protobufs to read in that text proto and cast it to the type T. Which is our parameterized type of the class. And then once the proto is read, we can get the background color. So again, we're using this reflection stuff, get background color. It's assuming the proto has defined a field called background color. If it hasn't, then it just defaults to white. So this get optional proto field will try to call get method on the method name, and if it does, if you get something like a no such method exception or some other exception, it'll just return an empty optional saying that field isn't defined. I also have get proto field, which is more like get required proto field, that will crash or exit in this case if the field is not defined. So for things like the width and height, which I want to make required, I can invoke this method instead. And I've written a bunch of simpler methods that call this and return primitive types, so they just perform the cast from an object within them. Same for optional. The cast is a little more ugly because you can't just cast the optional. You need to cast the contents of the optional only if it's present. And so that's the background color, similar for the scale factor, except I just set the scale factor to 1 if there's no scale factor defined. And that's basically the same as having no scale factor. And then we get on to some other methods that can do nice things I like to commonly do in my sketches. So one of them is freeze for some number of frames. So I have this method freeze frame, then invoke some runnable. So within the draw loop, which is being constantly invoked over and over by the processing framework, this needs to get called, and you pass it some number of frames that you want to freeze frame for. And it starts incrementing a counter that's hidden from the subclass, because this freeze frame counter is a private member. So it starts at 0. And in the draw loop, this is just going to get incremented every time until that hits this number of frames that you specified. And at which point it'll invoke the runnable by calling runnable.run. And usually you'll just specify this as a lambda or some reference to a function that you want to call once that number of frames has passed. And then it resets the freeze frame counter, and you can reuse this to freeze frame again. So if you have something like a state machine in your draw loop and you want to change states after some number of frames, you can, in the runnable, you can do something like, it would look like this. State equals, I mean, I'm just doing this for demonstration purposes. State equals state.foo. That could be your intro or whatever your the states of your animation are. And you pass some number of frames, like 10 frames. So that's that freeze frame, then invoke. Then I have these scale methods I talked about, and one that scales and then rounds to the nearest integer. Then draw background methods that pull in this background color that I've defined in my parameter proto. So whatever I passed for this value here in my text proto. And just some more convenience methods to set the fill color. And this color class is something I've defined myself. Maybe I'll show that. It uses an auto value, which is another very useful tool in Java from Google that lets you, it does a lot of the boilerplate for value classes. That is, classes that just hold immutable data that you don't want to change. So this is just like RGB values and then an opacity. And this isn't even used yet. Oh, hey, Ricky, welcome back. Mic could be a bit louder, thank you. Always on the tech support for me. Maybe I could reposition it too. Get it over here. How's it going, Ricky? Check, check, check. That looks good. I'll try to talk into it more too. So we're looking at this color class. No worries. Thank you. Great. Yeah, that's why we're streaming, so we can interact. So interrupt all you want. So this color class, yes, it's just RGB values, an opacity, and a type. Currently the type, I really only use RGB right now, but you can use, well, I imagine one day I'll want to use HSB, hue, saturation, brightness as well. And so that's how we store all our colors, and we have methods to convert them from strings, from an RGB string, which is what I specify it as in the proto. Something like that. And so I can just call set fill or set stroke, depending on what I want to draw with a color object. Then there are some useful methods for audio that I reuse a lot. So audio time, just given the current frame that we're on, tell me what time it is, and I can use that to basically cache up a list of audio events. Oh, mic is falling down. That I want to render later on, like when the sketch is done. And this -1 is just there because of a little detail with processing. It starts at frame 1 on the first instance of calling the draw method. In setup, it's called with frame count 0. So that's why the -1 is there, because I want the first call to draw to be the 0th frame. Then we've got the frame duration, which is just the reciprocal of the frame rate, which I always specify in a proto field. That's another field I get by reflection. I just pass the method name. Again, that was generated by Java. The field, I haven't added tests for this, but the field will be something like float frame rate. I think maybe that's what we'll do first, is maybe add some proto verification at the start of this class that gets invoked from settings. So it always, at the outset, kind of tells you what's wrong with your proto, your parameter proto, if anything. And then on top of that, or rather not on top of that, below that, I guess you could say, are these methods that retrieve a proto of a given type. So they all call this getProto field, which we all already kind of looked at. But this just uses a reflection call to get the method with that name, and then invokes it for the proto. So you can call, get background color, or get frame rate, or get whatever other method you might have. And I just do that to keep it generic in this class, because at this point I don't know all the fields that are going to be defined. I just know that it's a message, an instance of a message, which is the protocol buffer base class. And that's about all we have in this base class for now. So let's start with some verification and kind of crash nicely if there's something wrong with the proto. And technically I could do this even before I get the command line options. Because I'm verifying the proto definition, not the actual data. So the class that the proto becomes. I want to make sure it has certain fields. So I'll call it up here. Verify proto definition, let's say. And this is just going to crash with a nice clear message if there's something that needs to be in the proto but is not. So we are going to have to look at the Java class known as class, which is how you get access to all these reflective methods on the class. Maybe what I want to do is read all the methods that the proto has into something like a hash set of strings, so I can just check, does this method exist, does this method exist, etc. Or I guess a hash table, actually, because I want the string name. So let's say hash table. Actually, I think it's lowercase t. I'll import that if we can. Yeah. or hash map rather. Hash map is better. The only difference is null keys. I won't need any null keys for this. It'll be a string. That's method name to method. And the method you want to invoke for this is get methods, which returns an array of methods. So I can say method, actually, yeah, let's just do it within this, within verify proto definition for now. And let's make this a stream. Probably need to import the arrays class, yep. Stream, and then we're going to map this and collect it. I think as map is the method. We'll need to look that up. Java collectors, let's see, or to map, is that what it is? Yes, to map. So, right, I do need that get methods in here. And that'll be my proto-param class .get methods. So we're making that a stream. And actually, I don't need to map it at all. This should be fine. Functions.identity for the value, because we just want the whole method. This returns an array of method objects. Let me import functions. No, not that. I thought there was a Java class. Functions, maybe not. Oh, it's just function. Function.identity. That's a static method on the function interface. And then the key is going to be method. I assume it's get name. I'll double check the Java docs for that. Yeah, get name. I believe. Get methods. Yep, so that's our key, the method name. And this is just setting that to a map. So let me compile this, see if all is well. While that's compiling, we can think about what's next. We're going to want to check something. Okay, we've got some issues at 150. String and object. Let's have another look at the collectors. To map, yeah, you give it a key mapper and a value mapper function. Ah, yeah, I can't call it a hash map. Now, is there a collector to hash map? Maybe I'll just stick with to map. It might even be a hash map behind the scenes. That's okay though. It's some efficient map in any case. So that should work. Let's just make sure that compiles. Oh, I'll need to import map instead of hash map. And then down here, we'll want to check that it contains get width. And if it doesn't, we'll spit out this message. Must contain a width parameter. Actually, maybe what we should do is call get width method, because I want to make sure that its return type is an integer. So I'll say methods.get width. And then I can say check not null, because if that is null, that means you haven't defined width in your proto. We've still got a build failure. Ooh. Oh, duplicate key. Okay. Methods with the same name. Wow. And that was in one of the tests that happened. I think that was an issue with this class, maybe, or with this method. Let's see. Oh, yeah, yes, it was. Well, that is perplexing. This reflection stuff can get pretty ugly. So you can have methods with the same name. I guess if that's the case, I don't really care, whatever those methods are. So I'm going to change this. I will end up using a hash map rather than a stream. Let's just define a new hash map and iterate over the methods for method in get methods. Methods.put method.getName maps to the method. Now if there's a duplicate key, it'll just overwrite what's already in there. So rather than just digging into whatever strange method that is. Oh, of course, like if you override a method, yeah, you could override methods with different arguments that'll have the same name. That'll be it. And we don't care about that here. We just want to see if the accessors we want are present. So that looks good. Now let's modify our test. Let's say, I should maybe show the test setup as well. So what you do in test is you call this create for testing, which passes that Boolean I showed earlier, just to flag that it's in a test so it doesn't call the size method from settings, which causes it to crash. And you just pass it the name of a sketch and the proto class. That's for doing reflection. And then this is the generic type, the proto. Oh, and actually this should be the same. As what you pass. And I have a few different protos I've defined just for testing. So here, let's define a new one, something like message test proto with no width, where we just have height. For now, I can see that this crashes, and that'll be an assert throws method. So in the test, I need to set up these are the command line arguments that are being passed to the sketch. And it's just params and then the location of whatever the text proto is. And in this case, it's, again, test files I've set up that are in source test resources, which is Maven's location for any static data you want accessed by your tests. And so here I will need to, first of all, check the syntax of assert throws. So it is, pass it the exception that you expect it to throw. And actually, I need to call this within this runnable. So the assert throws takes a runnable. And maybe I want to do an assertion on the string of the actual exception as well. So let's see. Now I should look up this Jupyter assert throws method. Yeah, it has an optional or an overrided version where you can pass a message Now, I wonder if that's a substring or if that's the whole method. It doesn't say in their documentation. And it's actually not a runnable, it's an executable. Oops. Which is a Jupyter specific class, but it looks like a runnable for all intents and purposes. But yeah, I could say, I'm assuming this is just going to check for a substring. Let's see what happens when I invoke this. This should happen before I call the file, so I'll just make up a file name. Because it's before it tries to read the file, so this is immaterial. I don't need to define a text proto. Okay, failure. Oh, null pointer exception. Ah, maybe that's what check not null throws, actually. Let me check. This preconditions class is from another third-party library. It's from Guava, Google's big suite of extensions to Java with some really nice abstractions. Check not null. Aha. Yeah, it throws a null pointer exception. See, check argument is what throws the illegal argument exception. So we want to check that instead. The only thing I'm wondering about is this message. Actually, it shouldn't contain get width because that's not... I can just pass the whole message that I wrote here. Is it going to pass anyway? It's concerning. Let me have another look at that. Assert throws with message. Oh, maybe... Oh, okay, the message is not for the test. I think it's the message if it fails. It has nothing to do with what you're throwing. So that's okay. That's good enough for me. We don't really need to check the message contents. That might be making it brittle anyway. We don't want to change this message, and we don't necessarily need to change the tests if we just want to change the exact message. So let's move on. Okay, that looks good. So what else do we want to verify? Similarly, we want to do the same thing with get height. Let's contain a height parameter. Since we don't need to okay, I do need to define a new proto. Might as well have test coverage for it with no height. Test proto with no height. Looks good. Let's run that. Oh. Make sure I pass it the right thing. So now that I have both of these, maybe it is worth checking the actual exception message if I want to. Be a little more thorough here. Ah, so it returns a throwable. I see. Assert throws returns a throwable object that you can then inspect yourself with things like get message. Yeah. Okay, fair enough. So let's just say throwable t. And then let's assert that t dot get message contains... Oh, I'm in the wrong test here. Let me grab that. This is my color unit test. So there, we'll return the throwable and assert that it contains height. Or rather, in this case... Huh, did I not duplicate that other method? Let's see. Copy this, undo. Didn't mean to just overwrite my width checking method. redo it here. Okay, that looks about right. Okay, test no height in proto. So here we're checking that it contains height. Here we want it to contain width. So it doesn't matter what the exact text is as long as it references the fact that you're missing the appropriate field. Let's try that. Looks good. Okay. So we're checking that we have width and height defined. Now we're also going to want to make sure we have frame rate. Similar thing here, float frame rate. And I'll just use one of these other existing protos to add a test case. Just make a note of that. Params. And then we'll make sure the message references frame rate. And then I think that's good for now for verification. Then we can get on to some of the more interesting additions. By the way, MCP on the command line there, that's just an alias I've defined for Maven clean package, just to rebuild and test the whole package. Need to change this. Test. No frame rate. Okay. So in the future, hopefully all my sketches are going to extend this class, and it'll take care of a lot of the duplicated work for me. Okay. Let's see what happened here. Yeah. Proto must contain a frame rate parameter. That's... Ah, right. Now I'm crashing all these other cases. So I will need a new proto. Proto... And I should really add it to these other ones as well. Width. And then no frame rate. I'll use this proto to test. Frame rate. Everything needs a frame rate. You get a frame rate. And you get a frame rate. Let's go back here and grab this proto name instead. Back to our test. And we'll use this. Test proto with no frame rate. Looks good. Okay. So that's looking good for verification. And that's just invoked at the top of settings to make sure everything is kosher in terms of the proto you've defined. So to the meat of what I wanted to take a stab at this evening was implementing some fade abstractions so I can more easily make colors fade from one to another. And hopefully animating something to go from position X to Y, or at least facilitating those XY values frame by frame. So it's not something I need to repeat if I want to do that over and over again. So move something from X to Y in Z number of frames, or N number of frames, let's say. But first of all, let's look at the fade opacities idea. So I think we're probably going to want a dedicated class for this. And there is any number of fades we might want to happen concurrently, and you should be able to specify that from within the base class. So maybe I'll think about those top level functions that I want, or methods that I want first to inform the design. So we'll need something like start fade. And that will need some sort of index referring to the frame. So I'll need set number of fade. What should we call these? Any ideas? I could just call them fade indices, I guess. Fade elements. Set number of fade elements, int. Fade elements is good, I guess. And then that will pass the number of colors we need, or not number of colors, but number of objects we need to fade. And start fade should probably be passed the number of frames for which the fade is happening. And then maybe it can also pass the way that the fade happens. So we need to represent like linear fade, or maybe we want some kind of x to the n or x to the 1 over n type fade, so it starts quickly and then slows down, or maybe like a logistic curve, an S curve, or even just like a custom lambda that you pass. That would be the most general, and that's probably how we'll implement it. So we can call that, say, fade type. And this will just be like an enum within our fade elements class, which holds the list of these fades. So let's look at that class for now. I'll comment this out for the time being. So let's think about a fade elements class. And I'll just make a public static factory method. And in here we'll need some kind of list probably either a list or just an array is okay. It won't need to change size at all. So really, I think an array is all right. But an array of what? I don't want to do just integers. I want some other specific object for handling whatever data needs to be in there. So we could call this like a fade tracker. I guess fade element singular would make the most sense given what I did. Yeah, why not? So let's make another class. Fade elements. And so here we'll say this is a new array of fade elements. And so this start fade will need to pass the fade element index. We'll just call that fade element. And maybe in here is where we'll define this enumeration fade type, which has linear. Maybe this should be a class, actually, fade type, because it might need other parameters. Let's just assume it's linear for now and get the foundation of this written. We'll assume it's always linear. So fade needs a can be consistent here and use a factory method. And this will need a start fade method. And eventually the type, but again, we'll assume it's linear for now. Not count plus plus. We will set this, we will set count to number of frames. And what we will do is decrement that every time it's called from something like tick frame. So this will also need opacity, which is what we're returning. So maybe we don't need to store the opacity. That's what we'll calculate from whatever the number of frames was set to. So we can just start with this being 0. Actually, we can check state. Here, just a little precondition check. And let us know that you have to call start fade before calling tick frame. And then we decrement that. Only if the count is still greater than 0. And we'll need to import this. And maybe we want a different start opacity and end opacity. And we'll probably want to check if the fade is done, which we can determine from the count, whether that's 0. So now the opacity yeah, we might want to have both fades that start at full opacity and fades that start at 0 opacity, or maybe even any arbitrary opacity. I could see the need for that. So let's say, yeah, start opacity, end opacity, and we'll insist that these be passed. And so the parent PApplet has this really useful linear interpolation method. So let's pass in the parent to this class as well. We can use that existing linear interpolation function, lerp it's called, L-E-R-P. And we'll pass along all of these arguments to the constructor. So what this lerp method does is it interpolates between a start value and an end value, using some number between 0 and 1. And that number is going to be determined by the count relative to the number of frames. So I think this is accurate. 1 minus the count over the total number of frames of the fade. And then we can do this differently. If we want a non-linear interpolation, we can specify some other means of interpolating. But let's see. So if the count is number of frames, this is 0, which is what we want. We want it at the start opacity, whatever that may be. And if this is 0, then this value is 1, meaning lerp will return end opacity, which is, again, what we want. We'll test all of this. We'll write unit tests for all this, but just a quick sanity check. And that looks pretty good for a start. So, but now we're going to have to propagate all these, at least the parent, and then maybe start and end opacity should be flexible. Let's not worry too much about that for now. Let's just compile this. This will just be an array of null objects for the time being. Yeah, we're going to have to import PApplet. From processing, wherever it is. Here we go, processing.core. Both of these classes are going to need that. Just getting this out of the way for now. This is the parent processing applet. Okay, let's see if that compiles. I can start throwing the test file together. Actually, I just do it from test in the right directory. It'll be there. And I can copy this. This is fade element test. This looks all good. I am going to have to get an instance of PApplet in the test. That's something to keep in mind. So let's do one. I could just do this even, just to get a PApplet. I think that's reasonable. Call my AlgoMotion PApplet with a test proto. So we call create with the parent and the start and end opacity. So let's start at 1. Let's start at 0, totally transparent, and go to 1. So then we'll invoke start frame. Let's say we just want 3 frames for this test. Give this a name. A detailed name. Fade from 0 to 1. with 3 frames. And let's do 4 frames so I don't have like 1/3 to represent as a float. Even though we'll have to use a floating point check anyway, so we can't compare exact values, or we shouldn't, rather. So we're going to want to test tick frame and is complete. So first of all, after the call to start frame, element dot get opacity is within, let's say, 1 times 10 to the minus 8. I think that's good for a float. Is within that of 0, because that's the start opacity. And we can also assert that get complete is false. Prior to this, we can assert that get complete is true because it's not in the middle of a fade. That's all that is complete or get complete means. Is complete, not get complete. Yeah. Then after that, opacity should be 0.25. So let's see. Start with that. See how that looks. Okay. But was negative infinity. My. I set count to num frames. I didn't set num frames. You do need to set count. But we also need to set the instance variable. We were dividing by 0 there. Hence the infinity. That's what tipped me off so quickly. Now let's see. Okay. Looks like it is passing. Very nice. So we can call this tick frame. Let's do that for the remainder. Tick it until it's complete. So, yeah, 4 calls to tick frame and it's complete. That's what we want. Is true. And this is what we're going to have to expand upon to implement those non-linear fades we were talking about. Okay, that looks good. So let's see. Maybe we want like a fade function, some kind of transform. Maybe just an interface. And a pattern that exists is like, if you have a small number of implementations of an interface, you can make those as static classes within the interface. So let's call this and this is going to be a functional. Oh, functional interface. Yes. fade functions, fade function, Java. So the method we'll want for this is so this is going to take a float and return a float. So I think the syntax is extends function. If you want to extend an interface. I guess maybe I don't even really need my own custom interface. I can just have a bunch of lambdas. Oh, but like I said, yeah, maybe I want to parameterize them. So I think the function interface the main method is apply. Yeah, apply function float. Float that is, because it just transforms a float. So it'll be apply some value, and then now in here we can go, since I don't want a huge proliferation of class files in this case, because they'll be pretty simple, very short classes, I'll just say linear implements fade function, and this will have apply and this just returns value. So it doesn't do any sort of transformation. Let's see if that compiles. Gotta import fade elements, fade function. There we go. Yes, gotta import this. Which is, yeah, Java util function. Oh, functional. Java util dot function. Dot function. Function is the package as well. Okay. So now suppose we want to initialize this with a fade function. And down here, what we're going to do is apply the fade function to this. So now we can affect the shape of our fade. And with linear, it should be no different than it already is. I could consider making this a singleton even, where I just call get instance. It's probably a good idea. Let's do that. If the instance is null, we'll say instance equals new linear. This is just like a singleton pattern. So it doesn't waste time reinstantiating this class. And it has as a member an instance of itself. So, yeah, now this should work. Oh, I dropped some frames. Oh well, it's okay now. Right. This actually needs to be static. Because there's only one instance of the linear class accessible via get instance. And it'll default to null, but I'll just explicitly set it to null anyway at construction. Okay, that's good. And the test passed. So that's linear. Well, before I make a new test case, let's define some non-linear fades. So power will be a nice one to have. Now this one, I don't want a singleton because I want to be able to pass a exponent. I should make a note of what this does. Interpolation value x using x to the exponent. Not int though, float will be the exponent. And now here we'll say math.pow. And I think we'll need to cast that to a float because I'm pretty sure it takes two doubles, yeah, and returns a double. So we'll cast that down to a float. Let's see if this compiles. Which it does. So now we can try testing. Let's say x to the 2.0. So instead of linear, we'll do power. New power with 2 is the exponent. So let's for testing this is going to be a little uglier, so let's crank down the precision. That's why I don't need to specify 8 decimal points, because it won't be exact because we're squaring. And then in that case, let's just do 2 fades so I can delete one of these. So the first will still be 0. So after these calls, though, I'm just going to calculate this. 1/3 squared, obviously 1/9. Guess I didn't really need to calculate that. Yeah, and it's reasonable to just put in this test 1 divided by 9. And then 2/3 squared will be 4/9. And then it should end at 1. So let's see. Let's see if that passes. Okay, wow. Passed right away, so I like to break the test intentionally when it passes on the first try, just to make sure it's actually testing what I think it is. Just want to see it fail. Oh, I updated it. Maybe I did that too soon. Changing the file. Yeah. Okay, let's try this again. Very good. That's what we wanted to see. Yep. 4/9. Okay. So that looks good. Great. Another one I was interested in, while we're here, was doing like a logistic function, an S-curve centered around 0.5. And you can pass a growth rate as well. Usually that's 1. Call this K with the logistic function. So I'll allow the user to set that. Growth rate of K. And now this will be again, this has to be between 0 and 1. So it's just going to be 1 divided by 1 plus math.exp, I think is the name of the e to the power function. E to the minus k times value minus 0.5. Because it has to be centered at 0.5. And I want to cut it off. Yeah, I want to cut it off right at 0 and 1 as well. So actually, maybe I'll clamp the value of this float result. Get this out of here. So the logistic function is 1 over, let's pull this up. We've got Wikipedia here, of course. What else? When it comes to concrete matters, Wikipedia is excellent. So that's the logistic function. I don't know if you can see that. Can I scroll in? Zoom in, I mean. So L is just 1 because our maximum is 1. So it's 1 over, and it gives us this nice S curve. It'll be 1 over 1 plus e to the minus k times x, which is our input value, minus the center, the midpoint, which is 0.5 for us because we want this curve just going from 0 to 1. And we are going to cut that off at 0 and 1. We're going to clamp it. Now there is a clamp function somewhere. Where is it though? Okay, well we'll just use math.max and math.min, which looks like this, but with result instead. And we want a float casting of that. So it's the max of 0 and the min of 1 in the result. So that's effectively clamping it between 0 and 1. Maybe the processing method does some clamping. We can look that up. The linear interpolation method. I can see if it says anything. No, it doesn't. It just says value between 0 and 1. So I'll clamp it. Logistic. Now let's write some tests for the logistic function. Just copy this. And I should rename this test. 3 frames and logistic. So I'll just do a logistic function with k equals 1. Again, it should start at 0. And now we're going to have to calculate 1/3 Let me make sure that math function was correct. Math.exp. Pretty sure it is. Yeah, it is. Although I need to cast this whole thing to a float. And okay, off screen, I'm going to, actually, I still want that pulled up. I'm going to just manually calculate the value for 1 divided by 1 plus e to the negative 1/3 minus 0.5. I think that's correct. So I'm just going to copy in these decimal places here. That's the logistic function of 1/3. And of 2/3, it is, and actually I should round this up. 2/3, it is that. As long as I have more than 4 decimal points of precision, it's okay for this test. Let's see if that works. Nope, something wrong. Something is wrong. Okay. Was my calculation wrong? Let me double check that first of all. Given that it's this rather inelegant way of determining the expected value. E to the minus 1/3 minus 0.5. No. So what's going on here? One plus e to the negative k times x minus the center point, which is 0.5. Interesting. What we're seeing is it got 0.377. Oh. Oh, I see. That's this one. Ah, it has to do with my clamping. Yeah, I knew that was an issue at the outset. So maybe the logistic function isn't as nice as I thought it would be. I mean, I could fix the clamping, but then that's just going to be a big jump at the start. So I wonder if there's a better S-curve function that sort of naturally clamps. Let's see what I can find. Yeah, sigmoid. Sigmoid function, like the logistic, is the classic sigmoid function. Yeah, there are a ton of sigmoid functions. Where's the one I'm looking for? I can share this window so you can see what I'm looking at. Again, Wikipedia. What else? Hyperbolic tan. Yeah, that's not what we want. Smooth step. Ooh, yeah, smooth step. Yes. Here we go. Smooth step. Smooth step it is. I remember encountering this function years ago. Yeah. 0 is the left edge, 1 is the right edge. So what is the function here? Okay, clamp 3x squared minus 2x cubed. So that naturally clamps where I want it to, which is perfect. So I don't even need the clamp because what I'm passing it is always between 0 and 1. Very handy. So 3x squared minus 2x cubed. Is there a way to parameterize the shape of this? Ah, smoother step. Where? Okay, variations. Oh, wow. Okay. Well, I could implement both of these. Let's just start with smooth step, though. Forget logistic. Go with smooth step. And then there's no parameterization. So we can do the same singleton pattern that we did with linear, because there's nothing to parameterize here. So I'll do this same get instance stuff just because it's clean. And what we want is value squared. So return 3 times, oh, I don't do snake case in Java by convention, plus, oh, sorry, minus 2 times x cubed. So value squared times value. Nice. So I can get this off screen. Let me calculate the smooth step. So 2 of 1/9, or 2 times 1/9. Oops, no, 3 times 1/9 minus 2 times 1/3 cubed, so 1/27. Should be this. And then we'll do the same thing with 2/3. So 4/9 is 2/3 squared, and 8/27 is 2/3 cubed, which is this. Let's run that. Yep. Get instance. What's wrong with my get instance? Cannot find symbol. Ah, don't want to call new on that. It's just a static method. All right. That's good. That's good for now. While we're on this run here, let's just do that smoother step function as well, which was, where is it? Variations. Smoother step. Which is yeesh. Okay, I'm gonna. Nice, there's a C++ reference right here on the wiki page, so I'll just return that because that'll work here in Java. Value instead of x. Value times value times value times value. And I don't really need to test it at this point because it's sort of redundant. Just re-entering this formula. It's sort of, the test is a rewrite of the code itself. That's an indication that it's not a good test. So given that I've tested, oh, I didn't mean to, I did this again, overwrote the existing class that I had. I wanted a new class. There we go. So I have tests for these other three. And the real test anyway is the final product, what the sketch looks like. So if it looks good, that's good. That's another reason why with processing sketches you can take some liberties in terms of best practices, I think. Sometimes. Okay, awesome. So this fade element class now has the ability to do different kinds of fades between the start and end opacity. I do want to test opacity going the other way. 1 to 0. I'll just do that with linear, make sure it looks all good. From 1 to 0 rather than 0 to 1. So this should just be reversed, the opacity. Start with 1. Oops. And go down to 0. Yep, excellent. So now the question is, in this fade elements class, which is a collection of the fade element class, what exactly do we want to do? So in here I need, start fade, and then I'll need tick fade with fade element. And I'll also want to propagate like fade is complete for the given fade element. So within the sketch, it's always referenced by the fade element index. So let's go Yeah, do I want the ability to change the fade type? Probably not. But maybe. So typically I'll have some kind of proto that specifies colors or something. And in there I'll want to loop over and add elements. So maybe I don't want a fixed size actually, and I'll just use an array list instead of an old school array. And we'll go elements equals new array list. I could pass a capacity, but no need. No need. That would be just a small optimization. So I want to say add fade element. Maybe I could have this return the index of that fade element just in case it's useful. So this will return elements.size -1. And we'll just do elements.add element. And then, yeah, we'll want to see, we'll want to sort of just propagate all these methods, I think. But with fade element in as their first argument. That's like the index. These are just kind of forwarding methods that will just look into this list. For now, anyway, that's all they'll do. And then invoke start fade with num frames. This will be tick frame. Same thing here. Except I'll need to return that, and I'll need to return this. No arguments to these. Okay, let's compile that. Uppercase L. All right. Now this class is so simple. It's barely worth testing right now. I think we did sufficient coverage on the real logic, which is the fade element class, and the along with the fade functions. Ideally, I guess I should have tested these fade functions within a fade function test. They got their coverage from the fade elements test. That's okay. So now these can be implemented at the top level in our parent. I will add a private fade elements, which I initialize here by just passing the parent. You can do that anywhere. This is fine. Equals fade elements. Was it a, yes, a factory method dot create this. That's our PApplet. And now this is just a matter of, ooh, and fade type, right. So fade type will be when we add fade element. If in the future I want to change the fade type for a specific fade element, which is not likely, I can make the changes then to have this class look into that element and change the object that's stored there. For now, we'll just have it so that the fade type is fixed for any given fade element. And more forwarding of methods going on here. Tick fade. Is complete. Fade element. And then, of course, get opacity. Oops, no. All right. I kind of want to create some kind of simple sketch just to see this in action, and then maybe we'll wrap this stream up so we can fade color of 2 circles or something like that. So let me go ahead and just define. You just think about where I want to put this. There we go. Fade example sketch, we'll call it. Get this over here. I will have to define a proto. Well, you know what? I'll just use the test proto for now. Actually, this is in sketches, I believe. Yeah, sketches. So this needs to extend the class we're working on here with, we'll just use that test proto. I'll import algo. Actually, I should be able to auto import this. Yep. And test proto. Nope. So I couldn't auto import that because it's actually a nested class in the Java code. And the Sublime text importer is pretty primitive, actually. Like a lot of stuff in Sublime, it's not really an IDE, it's just a text editor. It has nice little plugins that people have made. But it's really just plain text. So here we need to override draw. And I'm going to need a little example proto that I can pass. Let's see here. Sketches. Just call that fade params. I'll make the background black. And we'll do, yeah, 720. 720 is good. For the size, here are fade params. Background colors, oh, frame rate. Yeah, we're gonna need frame rate. Let's just make it 30 frames per second. So let's see. Yeah, now I get to make use of all these fancy functions here. So I can go set fill. Just to make sure this is working, I'll set fill to red. And I'll make a circle. And I'll check. I'll just do this at like 200, and then I think the argument is just the radius. I'll go refer to the processing documentation. Circle, extent. Yeah, just the radius. So I don't know, 100. Oh, but I do need to I need to invoke the parent constructor. This stuff via, okay, yeah. Oh, this might actually pose some issues. Let's see, just with the processing framework. I don't know if it'll actually invoke this. Well, it must invoke the constructor somehow. So let's see, and this will be just test proto.class. Oh, I hadn't compiled since. There's still issues with this fade element stuff. Ah, I need to go import Well, no, those are in the same package. Method, tick fade. Oh. Tick frame, not tick fade. Yeah, and method add doesn't like add. Oh. Add fade element. I could really just call that add. Yeah, okay, now we're getting into this stuff. And I'm going to need that extra little, the main method, which actually calls the sketch. So hopefully this works. Should look like that. Our main method. Let's see. Let's see what we're missing here. Color. Doesn't like color. Oh. I should just implement or import everything from the parent class. And of course, we do need to import the processing core. All right. So now we at least get to see what's running. Java. This is my jar file, and then the package name. Fade example sketch. And now we pass it the params of sketch. Not in sketches. Where is it? Let's see here. Ah. Okay. So it's in source, main, Java, algo motion, sketches, fade params. Wow. There it is. Okay. So that circle looks kind of disturbing to me. I just want to set the stroke width. Stroke weight is the name of the method. Stroke weight to 6, let's say. Recompile. Let's just see how that looks. That's a little more satisfying to the eyeball. And okay, let's go. We'll have two floats here, alpha ball 1 and alpha ball 2. And we're going to try using these fades. Oops, alpha ball 1. That's red, and then this one can be green. It's alpha ball 2. Let's do stroke weight first. I'll just draw one ball there and another one at 400 with color 2. And in setup, we can call start, what did we call it? Start fade. Well, we need to add fade elements here first. Okay, so add fade element. Add one. Just going to copy all these as a reference. So this fade function dot smooth step dot get instance start opacity 0, so transparent, and end opacity can be 1. Here I'll just say set background, or no, sorry, draw background is the method we've defined in the parent. So this is really going to simplify a lot of repetitive code in future sketches. Then we'll add a second fade element. And you know what? I should return this and comment that maybe this can go from 1 to 0 just to switch things up. We'll do smoother step for this one. Okay, and here I want to go start fade for fade element 0, and let's give it 100, or let's give it, I don't know, 60 frames. So every 2 seconds at 30 frames per second, and then this one will do half that, 120. And instead of alpha ball 1, what we'll want is get opacity of 0 and get opacity of 1. So I don't actually need these. I do need to multiply. No, I don't need to multiply it by 255 because that happens in my set fill method. Yeah, it takes opacity and multiplies it by 255, which is what processing wants. What next? We need to call tick frame. I should really just have a tick all frames. Which moves all frames forward by one step. Tick frame, yep. So down here, I'll tick all frames. And I mean, this should give us two balls that kind of glow at different rates and with different phases. And the background will just be white, I think. Oh no, black. Let's go with white actually. Okay. Create with opacity, I think is the method that I want. Yeah, create with opacity. Tick all frames. Oh, yes, I do need to propagate that through one more time. Let's see. Okay, we'll at least get to watch something, even if it's totally wrong. Oh. It worked for a minute. Oh, right. Because we need to restart the fades. It's not a fade loop, so it is working. Fade is complete. 0. Then start fade. 0. And if fade is complete at 1, we'll start fade at 1. But then we have to recompile. See how this goes. Yeah. 3, 4, 3. Yeah. So it's twice as slow, the green one. And I could change the fade direction, but yeah, that would entail replacing the start and end opacity in the fade. So that is going to be a worthy feature to implement. So I think I will do that. Let's go public void set element int fade element. That's the index, and then the actual element I want to change it to. Elements Is it set? I think it's set in the list interface. I think the method is called set. So here we can just basically copy this and call it set fade element. More forwarding. Let's just call it set within that class. And just as one final task here before we go, what I want to do is I want to reverse the opacity. Order. So I want to start I want to toggle this. So maybe let's just do something like this. And then here we will go set fade element before we start it to this. Oh, right. And maybe I need a method like int opposite opacity of int opacity. Where we go return opacity is 1, 0, otherwise 1. Just to toggle that opacity. So I can go like this. Ball 1 start opacity, and then ball 1 opposite opacity. Do the same with ball 2. Actually, not start. I should say ball 1 opacity, because I am going to update this on the fly. Ball 1, ball 2. Here we'll go ball 1 opacity equals opposite of itself. And then we'll copy this. And start the fade. So we invert the opacity. Whoops. And start the fade. And then here, we'll do the same thing with ball 2. Invert the opacity. And start the fade. Let's try that. Oh. I did miss some code down here, but nonetheless that error looks odd. Let's try that again. Oh, no. Still doesn't explain that error. Let's see. What's the deal? Oh. Just extra remaining float there. I think we're good. Okay, let's see if this kind of toggles direction. Oh, didn't like it. Must call start fade. Indeed. Indeed. Ah, set the wrong element here. There we go. Okay. There we go. Sort of opposite direction fading going on. Nice. So that's really handy. A lot less code than kind of doing that manually every time and keeping track of the counters. It all happens behind the scenes in this fade element class that we just developed. So thanks a lot for hanging out and sticking around during the stream. Take care, and we will see you on the next one.